trust many of you guys are touching coding, and probably the last for many of you guys, considering I don't think any of you can do IT. But anyways, it's still something an important skill you need to know in the case of now the schools are pushing for it. So I'm gonna attempt to teach you guys basic programming on it, and to at least try and pass this robotics test. So if I'm looking at the breakdown of Mr. Guy device, it's may
I left.
Yeah, because you're hearing problems, huh?
okay,
Huh?
my network just builds up. Okay, anyways, so the first part is the void setup versus void loop. Now, if we look at this, you look at first of all, you need to know what both of them do. What? And it's in the name, it's quite self-explanatory which each one does. The void setup obviously sets up all of your components, and the void loop, it loops and loops and loops. However, we have to know it in more detail. The void setup is known for a few things. It's known for number one, initializing your pen modes. And this means it's your pen mode, you set it as an output or an input pen. Then the next thing is to start using sensors. It's to set up a specific sensor to let the Arduino board know that this is where the sensor is and this is what each pin is doing. And mainly we also do something called serial.begin. Now serial.begin, basically serial.begin, what the function of serial.begin is to initialize the communication between your computer and the Arduino board, specifically using serial. Now, we won't go into depth about the different communications like USB, serial, VGA, symbol. We won't go into depth, but serial is the only communication we will be using. Okay, now when we look at specifically void setup, that's what it does. And now with void loop. Void loop is used mainly, okay, well, 90% of the time what you're going to be doing with it is reading sensor values, for example, printing information, printing data, and it's advisable to have those that notes gave us in front of you, just because it makes teaching a bit easier for me. But if you don't, that's fine. Okay. Now, oh yes, in void setup, you're also initializing variables. Now, variables is a keyword because this is going to come up again later, so you must remember that. Okay, the void loop, it loops over and over again until stopped. It responds to our input controlling actuators. Okay, now the only way for me to properly teach this is if I do the examples with you guys. So do you guys all have a Tinkercad account?
No.
Okay, wait, I headphones. I just realized that can't hear anything. Just wait. Okay, that's better. Can someone just try? Someone say something so I can see if it's working. Okay, so I'll do it in a better way. I'm gonna host a Kahoot later at the end of the lesson because programming, Mr. Guy is not really teaching it properly because programming is something like maths. You need to practice on your own. You need to mess around in order to be able to understand it. So
At the end of the lesson, I'll be hosting a Kahoot that you guys, it's optional, you don't have to join, as if anything with the tuition. But it's recommended that you join because programming is one of those subjects where you need to mess around. Okay. Right. So you see, here's the base code that it's given with the Arduino when you put it into Tinkercad, and you can see that void setup. What it does is it's pin mode. It's setting up a pin mode. So one way to see to visualize this is to see how often it prints to the. So with programming, it's all about how you visualize things, how you understand it. Because initially, when you learn programming, you're going to be very lost, definitely. That's a given. But that's the fun part because eventually you'll get to a point where you understand everything at a high level. But that's not necessary for you guys. So most of you guys will never touch programming after this. But if some of you guys are inspired and whatnot, that's good enough. He ran multiple times. Right. Now, as you can see, we spoke about these points before. To initialize serial communication as seen here. Let me make it larger. To print important information and to set up sensors, right? Or outputs. Here is where you read sensors, you change sensor value, you change actuator data, actuators being your outputs, such as an LED, right? So as you can see, the void serial is ran once, the void setup, sorry, is ran once, while the void loop is run multiple times and will continue running until I stop it manually or if the board loses power. Now, that's the difference. Now, the main differences is this one runs once, this one runs multiple times. That's your main difference. It's quite obvious. But anyways, okay, the next is using serial monitor. Just bring that the serial monitor. Right. Now, the serial monitor is what allows the Arduino to talk to the computer. Now, it's not explained properly in this scenario. The serial monitor, you see this USB port over here. This USB port is where the serial data is transferred to. So if I have, for example, my phone somehow plugged into here with a fancy cable, I can read that serial data because it sends binary bits in this case, ones and zeros, and it converts it to USB protocol, whatnot, right? And this is how the Arduino and your computer communicate. It's over serial and USB. Now, what is serial? What is it used for? Debugging. Now, debugging is essentially seeing how your code works. It's like in maths. Take, for example, I have a complex maths problem, and then I just put it into my calculator, but I'm not getting the correct answer. Your next step is then to do it step by step. That's essentially what debugging is, to get the individual answers to see where you may have messed up or the calculate or you put in something wrong. That's what debugging is. Reading sensor values, in this case, is actually printing out serial values because we read the values on the board itself, and this is how you communicate the sensor values. Mm, They are printing useful messages to understand your program, such as here, as in my example, serial.print ran once and here is ran multiple times. Right. Then, now, the difference between print and println. Now, this is a key difference here. As you see, I've used println. Println stands for print line. What this does is, it's going to print to the serial monitor and then insert and then go enter. So if I open Word, this is essentially what it's doing. So let's just say it's going to print hello world. Right. With the print ln, what it's going to do is it's going to print hello world. Okay. Let's visualize this. It prints hello world and it goes to the next line automatically. Essentially, that's what print ln does. With with the normal print, it will not go to the next line. Meaning, what it's gonna do is it's gonna carry on printing on the same line, like this here. Now we're gonna visualize that. So let's make a simple script, right? We're gonna take all of this out, or let's just keep it, right? So let's just say one. Let's just say one. And now I'm going to convert this to a normal print. And what this is going to do is, it's literally going to print 1, 1 next to each other, as you can see. Now, that's the key differences. As in the notes, it says prints text without starting a new line and prints text and moves to the next line. Right? Thankfully, we don't need to know the escape sequences. Then, what's next? Okay, what is a comment? Now you may have noticed this orange text here. And essentially what this is a comment. Now, comments in code are not considered part of the program itself. This does nothing. I can take this out and the code still functions normal, the same way. It's because when this code is ran, it runs it line by line. But the minute you put a double slash or the slash followed by the dot, followed by the star for multiple lines. As soon as I do that, when the code runs line by line by line, it just skips over that piece of code. So it skips over this, it skips over this, it skips over this, it skips over this. Now, a comment's main purpose is to make it understandable to humans. The computer can understand it, sure. It's a machine, it will get it perfectly every single time as long as you've coded it properly. But humans will be lost because this is not plain English. Digital rights, for many people don't understand this. However, in order to make it understandable, we add comments. Now the comments describe what the code does as a general. For example, this is not commented properly because this does not explain very well what's going on. A proper comment would look like this here. The above code does X, Y, and Z. Like that. Because a good comment explains. Okay, and it also explains why certain code is written the way it is written. Because in coding, like maths, there's many ways to do something. Now, there's two main different there's two types of comments. It's a single line and multi-line, and that's quite self-explanatory. Now, with the single line, if I go here and I try and type something, it's yeah, that's no longer part of the comment. But with the multi-line, every line I add a star in at the start of the line, this is not code. This is not considered part of the code until I close it, and then this is again. So you can see that the multi-line obviously spans multiple lines with the star, and anything here is considered a part of the code. And for some reason, Mr. Guy has typed stuff every single line, even though it's unnecessary. But I suppose, whatever, right? Why use comments? Its clarity. It's to explain complex sections of code. And let's say if you want to improve your code in the future, that helps also. Right. Moving on, variables. Now, variables are a large section of coding. Essentially, what variables are, I'm not going to use the way Mr. Kai has explained it. I'm going to say that in your computer, who can tell me this? What? So, if I pull up my task manager here, right, and I go here, who can tell me what this is? This,
So RAM.
it's the RAM, right? RAM stands for?
Random access memory.
Right. Now, essentially, what that you have, so in computing, we use ones and zeros. This is a single bit. And when you say multiple, so and then when you have 8 bits, you get a byte, right? My laptop specifically has 16 gigabytes, which is an insane amount of ones and zeros that it can store. Now, in when you run your code and you have a variable, let's say you have an integer called x, and x is equal to 20, right? Now, what this is saying is inside all of those ones and zeros, a specific portion is now going to be known as x and will have the value 20, obviously with, and that's how a variable is basically a piece of your RAM or your memory, however you remember it, that can be changed. Now, when I run this code here, obviously this is running on the Arduino, and I have a variable. Let's call it x, and we're going to say it's equal to 20. Anytime I edit this variable, I'm editing the RAM on here. So x is equal to x plus 1, and let's say, and let's print it out to see how we can change it. Right, so if we run this code, okay, wait, let's take this out. Okay, when this code eventually runs, because the site is quite slow, you will see that, okay, whatever. Alright, you need to, okay, well, I don't really program in this language, so just excuse all the errors that may have happened. Okay, anyways, so every time if the code runs, you can see we're increasing it by 1 every single time the loop runs. Now, every time the loop is ran, we modify this section of data and we say, okay, this is now a 0, a 1, this is now a 0. Every time we run this code because now we're editing the variable. So you get many different types of variables. However, there's 3 we need to know specifically. That being the Boolean, spelling counts, the int, and the float. Now, who can tell me what a Boolean is? Okay, I'm just gonna assume from now on that you guys are starting with no prior knowledge. Okay, a Boolean, it's a true or false type of variable. It's either true, it's either false. Now, if you look at it from here, it's either true or false. True being 1 and false being 0. Would you look at that? Now, we know that the Boolean is 1, has 1 bit in it. Okay, you don't need to know this, just a bit of extra information. And it's either on or off, true or false. That's the only type you get. Then, the integer. This is quite self-explanatory because um, because obviously we do integers in math, so it's without the fraction. has no fraction or decimal part. It's a number, it can be positive, negative, whatever. Now the float. A float is a number with a fraction or decimal. Essentially, your rational numbers. Think of that there. So then, now we're going to experiment with the different types. Now, as you can see, I've already used the integer type here. And now let's use a float and call it y. Let's use a float. Let's call this float y, for example, and let's say this is 110.10. Okay, right. Now we can see, okay, let me also do a boolean and call it z. And a boolean is either 1 or 0, true or false. Now I'm not going to be manually typing out the stuff because we don't have the time for that. So, okay. So my browser just decides to quit on me. Sure. I think because, okay. Anyways, right. ChatGPT. Float. Okay, right. So I'm not going to spend all of that time typing all of those things out. Right. So I have asked ChatGPT to write my code. Now, really, they don't assess code properly. Right. As you can see, here's the Arduino demo. Boolean, integer, and float. This sketch shows how each type of data works. So let's go through together. Right. So it creates a Boolean called LED state, and it says it's true. So true being 1 and false being integer, counter. So it's an integer is a whole number with no decimals. Okay, that's partly true. Float and temperature. Here void setup, serial dot begin. So it's starting the serial communication. As you can see, ChatGPT has made good use of comments. So it sets the built-in LED to an output. Right. Now, if LED now let's run this code and see what it does. We'll go line by line. So it's saying if the LED state is true, then digital, right? And you must set it to high, right? Then, and you must print LEDs on. But let's say it's false. Then it's going to run else. And it's going to set the built-in LED to low. And it's going to say the LED is off. Boolean is equal to false. Now, this flips. Okay, you don't need to know this, but this exclamation means flip it around. Essentially, it's saying not LED state. So it's saying the LED state, whatever it is, must be the inverse. And it prints the counter, and every loop it increases the counter by 1. And as long as the counter is less than, the counter must be less than 10, or else it resets it back to 0. Now the temperature float, it adds, just has 2 decimal places, and it increases by 0.1 every single time, and there's a delay. So if we run this, you can see it sets it to true, it sets it to false. As you can see, it's toggling on and off the LED, it's printing the temperature, it's printing the integer, and it's using Boolean. Does everyone understand everything so far? Is there any questions regarding variables specifically, or any other thing, concept I've covered so far? So, based on the information, if I give you a word problem, will you be able to code using the concepts I've taught you? Yes, Ziegler. Okay, I'm assuming that was a mistake. Anyways, moving on. Um, the key characteristics of a variable. Variables must have these things. They have a name. Each variable has a name. It's quite simple. For example, your counter, that's your name. Then it has the value which it stores, in this case 0. Then it has the type of variable. So obviously this is an integer, so it's only whole numbers. Right. Then the scope. Now, scope essentially is where the variable can be accessed. So if I put this whole block into my loop, it won't be able to be accessed out of void loop because obviously it has to do with where you assign the memory and a whole bunch of complex stuff that I'm not gonna try to explain. Okay, now why? Yes. Okay, wait. I'm assuming something.
Sorry, what page are you on? Like
Page 14 of the booklet.
14.
Yes,
Okay, thank you.
no problem. Okay. Anyways, why use variables? So we need to store data in some way. Let me just close WhatsApp. Okay, anyways, we need to store data in some way because, well, you only look at it when you're doing more advanced programming, slightly more advanced, but we need a way to counter. Every time this loop is run, we need a way to track how many times this loop is run. So we need to store data, right? To make it more readable, so to use meaningful names, for example, LED built in instead of the actual name, which is vector 00.2, I believe, or something for an Arduino program. So essentially, LED built-in is a type of variable, I can argue, right? To make it easier to modify, because if your value needs to be changed multiple times, you can easily change it on the fly, right? You don't need to know the naming conventions. Um, Keyword. So a keyword or reserve. Wait, do we need to know that? Okay, yes, keyword. Just the first paragraph. Okay. Now a keyword is a reserved, also known as a reserved word, is a special word that has a predefined meaning. An example of this is serial.begin. So now I cannot make a variable called serial. We can try, and it will 90% of the time spit out an error. It should spit out an error. You see? Okay, well, my besides that, it shouldn't. You see, it's saying you previously declared serial. Obviously, that being a already declared word, meaning predefined meaning. You cannot change that variable. We cannot use serial as a variable, right? So um, the computer already understands serial as okay, serial, it has to do with communications. Now I can't create a variable called serial because of that. Okay, data types, we just went over that. Control structures, if or else. As you've seen before, the if true, then it runs this code. If it's false, there's an else block and it runs that code. Quite simple. The operators, that's self-explanatory because it's less than, greater than, less than, equal to, greater than, equal to, times, divide, and add. Right. And essentially, this is used in something we call logic and arithmetic. However you say that word, right? Arithmetic, right? And the so the first few ones, the less than, greater than, less than, equal to, and greater than equal to, are all used when you're if or else. So let's generate a program doing that. Now, essentially, you just need to be able to use these things, right? So I'll go over this code in depth with you guys now. But first, right, let me just, right. So essentially, it creates a few numbers here and is greater, right? It starts the void setup, right? Now we're saying that, okay, serial.print, whatever, print it. Now it's saying A plus B and print. Let's run it and we'll go over it line by line. Right. Now that let's clear it and run it again. Right. Now, A plus B is quite simple. A minus B, A times B, A divided by B, and percentage is to get a remainder when you're dividing. Because because A and B are both integers, will only return an integer. So let's say I have 2.5. It's not going to round it. It's just going to say 2. And then obviously this to get a remainder. Right. This is just comparing is greater than less than simple stuff. Simple operators like this here. With floats, obviously that's just more complex. Moving on. We got pin mode, digital write, delay, serial dot begin, serial dot okay, I went over serial print and serial print line. Right. Pin mode, quite simple. It sets a specific pin to either as an input or an output pin so it lets the Arduino know, okay, this pin is to be used as an input pin, for example. And the way we use it is, you would have seen earlier, let's discard this one and bring out a new one so we can use the base code. It's saying pin mode. The LED built in must be an output, well, obviously, but in this case, we can set, for example, pin 2 as an input pin, right? Digital write, quite simple. Once you've set up your pin mode, when you use digital write, you are essentially changing the value of that pin when it's an output pin. So either 1 or 0 with the asterisks considering PWM, but I'm not going to get into that. And essentially digital write will set it either to high, which is on, and low, which is off. This is how you write digital write. Okay, delay is simple. It's in the name delay. It just delays it by however many milliseconds specifically. Okay, right. I've gone over literally everything for the test, so is there any questions before I create the code?
Nah.
Are you guys keen on doing it? Because I'm not going to waste my time if you guys don't want to do it. Okay, right. Then I will send the link now, but if there's any other questions, just let me know.
No.
Thank you, Big P.
No
Thank you,
problem.
Pravir.
Yo,
Oh,
wait. Big P can
Thank you,
carry
Big
this
P.
on, bro.
any of you guys doing IT next year?
No,
Um,
no, 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 Big P.
Okay, so as a teacher, I should be saying you want to I want to push you into IT, but I'm not gonna do that because doing IT requires a different way of thinking. So most of you guys are gonna be sitting in CAT next year, essentially.
yeah.
Most
Yeah, well,
likely.
if it gets you the higher APS points, take it.
But thank you, Big P. You're the
Thank
goat,
you,
bro.
Pravir. Lesakho, please keep quiet.
Okay.
Big P,
Yes.
could you please just go over like the code that they're gonna give us tomorrow?
Oh, what do you mean?
Like, didn't he say that? Did he give you guys like the exact code? Or not exact, but like a similar one.
Yeah, so he gave us examples. So obviously, I'm gonna be doing that with you now.
Yeah, can you give me like the examples he gave you? Because I wasn't in class when he was doing that.
Okay, well, I don't have the exact examples. I can give you quite similar examples, obviously along the same
Yeah,
lines.
yeah, can you give me similar ones?
Yes. So I don't think I'm going to be doing a Kahoot because that's a lot of setup. So I'm just going to say, like, give me basic examples to do where
Wait,
I'll
do we
go through
know
it.
how much
Yes.
the test is out of?
No.
It's out of 40.
40. Hey, that's not a lot of marks. That's actually quite a much.
And the actual code is 12 marks.
Oh, so
Actual
like,
code. Oh,
Yeah,
oh, so obviously, like, he's going to be asking general questions like, what is void setup and how is it used?
yeah, it's
oh.
gonna ask me that. But like the actual code that we have to code is 12 marks.
So realistically, it shouldn't be that.
Yeah.
Hopefully.
Okay, let's see. There we go. Okay, I'm gonna cut it at 5. Okay, let's do all 6 of them together. Okay, can you see this? Yeah.
Yeah,
Okay. Right. So what I'm gonna do is I'm gonna have the Arduino programmer open and then you guys will be able to I'll help you guys go along with this. Yeah. Okay, this is the wrong Google. Okay, there. Right. So exercise 1. Create a Boolean variable called switch state. Make it start as true. If switch state is true, turn built-in LED. Or, excuse me, if false, turn it off. Add code that flips the boolean. Okay, you don't need to know this, but this is just a bit of extra information for you guys. Okay, so first of all, what what are we doing here? So assume you got nothing here. What's the first thing? What are we going to be
I-
typing out first?
isn't it void setup?
Yes, void setup. You always start with void setup. Okay, key thing to note, I didn't say anything about this. That's my fault. But what does anyone know what void means in the sense of coding?
No.
Okay, void meaning when I run this setup and let's say I modify a variable. When I run the setup specific in a very specific way, it's not going to return any value. Void meaning no, like emptiness, no value. Simple. Right. What are we doing in void setup?
Um, isn't it like the stuff that only gets run once?
Which is in this case, what pins? Okay, let me narrow it down for you guys. What pins are we modifying? What things are we gonna do?
Um, Boolean or Boolean?
Okay, wait. Let me. Okay, this is a key thing to note because I think I glossed over it too much. Your variables, your key characteristics of a variable is that where can it be modified from? If I put this in the void setup, what will I be able to access it from the void loop?
No.
No, you won't, right? Because let me turn to the page and get the proper name for it. Oh, it's called scope. Right. The scope of the variable is now limited to void setup. So we would actually put this here and call it switch Now, for the purposes of coding and helping you guys understand, I'm gonna be doing it over 2 lines, and it's gonna be true. Right. Now, in your void setup, who can tell me between, okay, okay, it's just the three of us. Anyways, between the two of you, who can tell me what happens here? What are we gonna do? Type in here.
We're gonna like basically set up the components
Yes,
with
so that being it starts with a P. Specifically, what's the name?
your pen mode.
Pen mode. Key thing to note, where you put your capitals and that matters. Your pen capital mode, right? And it's gonna be the LED built in, and it's gonna be an output built in. Right. Now, what else? Now, what's next? It's a void loop. Right. Now, what happens here in the void loop? What are we doing?
Basically repeating the how would you
Okay.
say
Let me
like what's
rephrase that. In the case of the program, we've already done both of these things. What is the first thing we're going to type here based on the instructions?
Digital rights.
Okay, you close because we saying if this condition is true, we must turn on. So you are close. It's an if loop. Now the way you do it is you type it's if and with brackets. Now we say if switch state is true. Now when I do it like this here, it's gonna return true. So I don't need to say is equal to true or is equal to true. So okay, I forgot to ask this question, but what's the difference between one equals to sign and two equals to signs?
The two equal to signs actually means equal to, right? Like they actually equal to.
No, the one means that thing. You say
And then I
it's
didn't.
okay. Wait, let me rather just tell you because I think I'm also confusing what you say. One means you setting the variable as that value. Two meaning it's checking if these two are equal. Okay, right? And now we're saying that if switch state is true, what must happen? We're gonna digital right, and we're gonna say LED, and we're gonna say oh sorry, and we're gonna set it to high. Right. Now what's gonna happen? We got our else. Now we know, okay, if it's true, it's gonna turn on the LED. As you can see if I run this code. Something's wrong. I typed in something wrong. Shouldn't be taking this long to initialize. Okay, there we go. Right. Switch state. Something. Both. Oh, spelling counts. Built in. Switch state. I think it's one or something. Maybe I spelled something incorrectly. Okay, when in doubt, ChatGPT. Obviously, we will not have ChatGPT during the paper, but for learning purposes, I suggest you use. Right. Let's see what this says. The else block is empty. Oh, okay. Well, that's just silly. programming, because I didn't put anything here. I didn't cover all the conditions. So I'm just gonna do this example, and I'm gonna post the other examples on the group. You guys can do it on your own if you want, and just send it to me. This is just a bit of okay, whatever now. Why is it okay? What this makes no sense, but anyways. Okay, there we go. Right. Now we see, okay, the light is on, meaning this is true. But we need, okay, well, we don't need to know this. But how do we switch it? Now, there's a very specific thing to do. We're going to say switch state is equal to switch state. But there's a very specific thing we're going to put in the front here, that being an exclamation mark, saying, okay, switch state must equal to not switch state, meaning the inverse. And this is essentially going to allow us, okay, well, we need a delay. There's a delay. Generally, 90% of the time, your code must have a delay, or else you're going to crash the actual thing because it's going to be running at max speed. Okay, then this is the code done. If you want, I'm going to post the exercises on our group. You can, and I'll send it to you, Tian. Go through it in your own time and send it to me, and I'll tell you anything. But this is just mainly the whole point of learning robotics. You should be learning how to think like a programmer, not how to code. Because in order to code, you need to be able to understand and break it down, how what the instructions give you, then be able to put that into physical code step by step. Okay, but that's everything from me. Say anything else you, if there's anything else you don't understand, I'm be online till 8.
Okay. Thank you, Pravir.
Okay,
Thank
okay,
Appreciate
you,
it.
bye.
P.